Now we will demonstrate how the Huggable can be controlled remotely via a joystick on the parent or teacher's computer. The Huggable's head can move left and right, as well as up and down via this interface. One thing to note is that as the Huggable moves its head, the virtual Huggable and the camera view on the website provide a clear indication of where the Huggable is currently looking. In this next video, we will demonstrate one of the autonomous capabilities of the Huggable robot, the ability to look at people's faces without external control. As shown in the Huggable Eye Camera Viewer, when the Huggable sees a person's face, it places a red box around that face. The Huggable then uses this information to keep that person's face directly in the center of its field of view. Such a system can help the human operator by allowing them to focus their time on the interaction and not with keeping the Huggable constantly looking at the person. Here, we demonstrate another feature of the Huggable system, the ability to quickly and easily select which person the Huggable will look at via labeling. Here, the Huggable is currently looking at Alan. Using the website, the current location of Alan's face is marked and labeled, and a push button for Alan is created. Next, using the joystick control, the Huggable is turned to face the next person, in this case, Dan. Once the Huggable is looking at this new face, the name of this new person is marked and labeled, and a push button for Dan is created. Now, at the push of a button, the Huggable can turn its head back to Alan and back to Dan. As shown in the video, the marked positions provide a rough location of the person's face, and the autonomous look-at behavior autocorrects to keep the Huggable looking directly at that person. Such a system has much benefit in the case of a parent interacting with more than one child, or a teacher trying to teach a group of students via the Huggable robot avatar. By reducing the cognitive load of controlling the Huggable robot with a joystick to constantly move back and forth among people, this interface opens the door to much more engaging interactions. The website interface to the Huggable robot avatar allows sounds to be played back in real time on the robot at the click of a button to enhance the interaction. The inertial measurement unit inside the Huggable robot is used to measure the current orientation of the robot. This information is then displayed on the website to allow the operator to have an idea of how the child is holding the robot and thus can incorporate this information into the interaction. Additionally, the live camera feed from the Huggable's eye camera is offset by this rotation, which helps to keep the operator from getting seasick, and it helps to keep the face detector algorithm working even when the robot is on its back or its side, as shown in the video. The inertial measurement unit is also used to detect specific gestures, and this information is displayed on the website via the animated Huggable graphic. These gestures include conveying if the Huggable is picked up, bounced up and down, or rocked back and forth on its back. Finally, a set of passive potentiometers in the hips and ankles of the huggable robot is used to detect if the child is playing with the feet of the robot. This information is displayed on the website and can be incorporated into the interaction.